Welcome, everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to write a formal proof to show that two triangles are congruent. How are we learning it? Through the Congruent Triangle Proofs Part 2 notes and the Congruent Triangle Proofs Part 2 assignment. When can we use this information? To formulate well-thought, articulated arguments to defend your opinions on various topics. How do you know you learned it? By getting a score of 4 on the Congruent Triangle Proofs Part 2 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Congruent Triangle Proofs Part 2 notes, and then I'll give you time to complete the Congruent Triangle Proofs Part 2 assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your before you go. Your only homework for tonight is to continue working on the Geometric Proof Study Guide and any incomplete assignments that you may have. Let's take a look now at the Congruent Triangle Proofs Part 2 notes. The notes begin with the learning goals and success criteria. Now, understanding congruence. In order to show that two triangles are congruent, we must show that all the sides and all the angles are congruent. So first we need to state the parts that are congruent. Well, we have AB here with a single dash, and we have DE here with a single dash, so those are congruent. Now notice, I said AB is congruent to DE. I didn't say AB is congruent to ED, because that is not a true statement. In order to make a true statement, I need to follow along with the corresponding parts. So I went from the end point with the double arc to the end point with the 90-degree angle. So I need to do the same thing here. End point with the double arc to the end point with the 90-degree angle. So it's AB is congruent to DE. Then we have BC here is congruent to EF, and AC is congruent to DF. So those show that all the parts are congruent. Then I have my angles. Angle ABC is congruent to angle DEF because they're both 90 degrees. They both have the box. Then I have angle ACB, so the single arc, is congruent to DFE, single arc as well. And then I'll do my double arc. So BAC is congruent to EDF, and those are congruent. So now we've shown that all the sides and all the angles are congruent, so therefore the triangles are congruent. So we can now say that triangle ABC is congruent to triangle DEF. Now let's take a look at side-side-side congruence. And what side-side-side congruence says is that if we know that all the sides are congruent, then the triangles must also be congruent. So again, we can say that AB is congruent to DE. We could say that BC is congruent to EF, and AC is congruent to DF. Therefore, we know that the triangles must be congruent because all of the sides are congruent. So because of side-side-side, we know that triangle ABC is congruent to triangle DEF. Now let's take a look at side-angle-side congruence. So side-angle-side congruence says that if we know that two sides and the angle between them are congruent, then the triangles are congruent. Now notice here, I have a side, an angle, and a side. The order matters. If I had a side, and I knew this angle, then this theorem would not work. The only way it works is if we have the two sides and the angle that goes between them. So here we know that AB is congruent to DE, and between them we know that there's an angle here, angle ABC, that's congruent to angle DEF, and then we know that side BC is congruent to side EF. Therefore, we have two sides and an angle between them that are congruent, so therefore we can say that triangle ABC is congruent to triangle DEF. Now let's take a look at angle-side-angle congruence. The angle-side-angle congruence says that if we know two angles and the side between the two angles are congruent, then the triangles are congruent. So if you notice, we have an angle, a side, and an angle. Again, order matters. So we have the side that we know comes between the two angles that we know. So then let's restate what we know. Well, we know side AB is congruent to side DE. We know angle ABC is congruent to angle DEF. And we know angle BAC is congruent to angle EDF. So therefore, we have two angles and a side between them that are congruent, so we can use the ASA theorem to state that the triangles are congruent. So we can say triangle ABC is congruent to triangle DEF. Now let's take a look at angle side congruence. So this says that if we know two angles and then the side after those two angles, then we know that the triangles are congruent. So here we have angle ABC is congruent to angle DEF. We have angle BAC is congruent to angle EDF. And we have side AC is congruent to side DF. So we have two angles and the side that comes after them are all congruent. So therefore, we would say the triangles are congruent. Triangle ABC is congruent to triangle DEF using angle side. Now, what are vertical angles? Vertical angles are a pair of opposite congruent angles formed by intersecting lines. So we have two lines here, and they cross each other, and notice that we have two angles that are formed here and two angles that are formed here. Vertical angles form an X pattern, and the angles that are opposite of each other are congruent. So this angle and this angle would be congruent, and this angle and this angle would be congruent. Now, what is a geometric proof? A geometric proof is a step-by-step explanation that uses definitions, properties, postulates, and previously learned theorems to draw a conclusion about a geometric statement. A geometric proof is typically done in a two-column proof with one column being the statements and the other being the reasons. So what do geometric proofs look like? They look like this. So we have a column here that represents our statements. This is what do we know? So these are the statements of we know this, we know that, and so on. Now the right side is the reasons, and that is the arguments for how we know that's to be true. This is an example of a geometric proof. So it says AB is congruent to DE, and we have our reason as given. Given information is the information that they told us. So whether it's a marking or they state it in words, whatever it is, the given information is stuff that we didn't have to figure out on our own. It was told to us. Then we have AC is congruent to DE, given. Angle BAC is congruent to angle EDF, given. And then the triangles are congruent. Notice all of this was given information, but this part we had to come up with on our own, the SAS theorem, to prove that those triangles are congruent. So we use the theorems and postulates to fill in the rest of it.
Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google.
Let's take a look now at the Congruent Triangle Proofs Part 2 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take us to Desmos. Go ahead and click on that link, and it should take you to a page that looks like this. We'll go ahead and click Start the Activity. The activity begins with the learning goals and success criteria. Go ahead and click Next. Now for this one, we're given a proof that's partially filled in. We need to fill in the rest. So we have BC is congruent to YZ. So we're going to go ahead and do this so we can say that also AB is congruent to XY. And I'm just going to go ahead and copy this congruent symbol here. So it's congruent to XY. And that is given because they have the markings. And then we also know that this side and this side are congruent. So we can say that AC is congruent. Again, I just copied and pasted this. AC is congruent to XZ. And that's given. Now BC was congruent to YZ, and that was given as well. And we can check each of these steps. So the first one, we can check the step. It says AB is congruent to XY, given. And it shows us that's right. Then when we did this one, then we can check this one, see that we did it correctly. We could check step 3, see that one was done correctly as well. Then we're going to put in our stuff for step 4, which is that triangle. So I'm just going to put triangle, T-R-I, triangle, ABC is congruent to triangle, and we can go ahead and say XYZ. And how do we know that? Well, we have 3 sides, so this is the side theorem. And now we hit check step 4, and we can see that that's correct as well. And we can use this triangle now to copy and paste it if we'd like. So we can copy this, and we can use it on our other slides as well. So there's triangle ABC is congruent to triangle XYZ. And then we'll move on, and we'll do that for each of these. So we're given different triangles, and we're going to state what we know and how we know it. So you'll do that for each of the remaining ones. Now let's look at slide 6 here. So it says AC is congruent to EC, right? We know that's true. So we'll copy this again. AC is congruent to EC. And that's given information. We'll hit check the step. We can see that that's true. Then we have angle ACB. So ACB is congruent to angle ECD. So this angle and this angle are congruent. Well, there's no markings, so it's not given. So how do we know that? Well, we should notice that this forms an X shape here. So anytime we have an X shape, we know that by vertical angles, the opposite angles are congruent. So we could say that these 2 angles are congruent because of vertical angles. So I'm going to type in vertical angles theorem. We hit check step 2. We can see that that's correct. And then we'll fill in the rest of the proof. So we'll state that BC is congruent to DC by given, and then we can state that the triangles are congruent. And then we'll finish this up on slide 7. And then when you're done with this activity, you'll go ahead and go back to your Google form and click next. This will take you to your before you go. Go ahead and fill out your before you go, and then submit your work on Google Classroom.